been just hired. So yes, there will be more groups, and then those students who have not been grouped, they will be added to another group. So what we can do generally is until the next week, if there's some students are still not yet grouped, then they can just send me an email, or during the discussion you just let me know so that I write everything down or take the student numbers, then send them. I prefer to have, let's say, all those who are not grouped in let's say one batch, then I can send it once and for all, so that at least the guys who does the admin, I wouldn't have a lot to deal with. Okay, any other question? And please, guys, let's practice some harmony here. If you want to ask a question, please raise your hand so that I can know which order I'll follow. Yes, please go ahead. The recording has started already. Yes, go ahead. Who's the person who want to ask? Someone was talking. Can you please ask, unmute and talk? Okay, so if you are not talking, then guys, okay, please, what you need to do is please raise your hand so that I know who's the person who want to talk, and then we'll follow up from there. I'm going to come later on and include the recording here in this page. So for now, what I would do rather is just to start from page number 2, so that I can have that space to include the recording. Okay. Now, where we start is generally because we're going to start with the first chapter. And then in the first chapter, is there anything, guys, you want to ask me before I start? Or should we start first? Okay, if you're not saying anything, please, if you need to say...
Hello?
Okay, I see a hand is up. Yes, Eben, go ahead.
Yes, just want to ask, are you going to upload these recordings on my UNISA?
Well, of course, if we record it, so we're going to upload it on my UNISA.
Okay, thank you very much.
All right. Okay, we're going to start with the easiest notion that you guys are already aware with from high school. You have the set, you all know the set of natural numbers. So if you are from an English-speaking country, usually you know the set of natural numbers starting by 1, 2, 3, 4, and then so on, so forth, until infinity. Why we call them natural? Because yes, previously the ancestors, they know how to count using other stones, or using the number of cows, or number of sheep, number of goat, and so on and so on and so forth. And that's why it's called natural, because everyone knows how to use it previously, and then it's become. Then later on, mathematicians discovered that there is a 0, and then they added to this one. So it's in a way, it's I'm going to write it here, and I'm going to explain when we get to the notion of set slightly differently. And then like 5, 6, 7, and then so on and so forth. So there where the 0 came in. And then this one, they usually called integers. And most people call them specifically natural integers. So starting from 1, 2, 3, 4. So natural integers, and the n is the set of natural numbers, or you can call them natural numbers. Natural integers is the same thing. Okay. Now the next one, after this ones, later on mathematicians have discovered from the Europe that once you have these numbers, you can also, if you have one cow and that cow dies after some disease, then that means that you don't have that cow anymore, then you get a 0. And then the question is that how is that going to be expressed? So then if you have something that is 1 here, and then that thing is not there, then the opposite of that is going to be a -1. And then this, in a similar fashion, then they discovered that, oh, you can have a -2, -3, -4, and -5, and so on and so on and so forth. With that in mind, then they discovered that they can actually write a set of integers, and then let's say start here at 0, 1, 2, 3, 4, and then so on and so forth. It doesn't end. And then in this side, it's going to be -1, -2, -3, and so on and so forth. It's also going to go and non-stop. So that means that you have the integers, or the natural integers, adding the 0 to them, and you have the opposite to those ones. So when something happened in the opposite direction. So if you have a sheep and that sheep died, then you subtract that sheep out of the number of sheep you have. or if you have a goat and then one of the goat got eaten by a lion or by a loon or by any animals, so then you're going to remove it out of that total number that you have. So that's how these opposite numbers have been. Sometimes you call them opposite with respect to the addition, because you are removing something from a total number. And now, if we try to look at it in a nice option, we're going to say, okay, if we have the set of natural numbers, let's say we call it n, then I can just write it just like a box, like a bag, to say that it contains all these numbers 1, 2, 3, 4, 5, and then so many of them. So 1, 2, 3, let's say 4, 5, and so on and so forth. There are plenty. I can enumerate them all. Then the other one, the set Z, because it has all these natural numbers, and it has something extra like a -2, like -10, -11, and so on and so forth. So mathematically, when we get to the notion of sets, we're going to literally call this outer bag, this one here, we give it a different name. We're going to call something called the complement. So it's complementing what is inside. What is inside on its own was not enough, so then this guy is complementing it. So then the one there is called the set of natural of integers. Z is called the set of integers, and the set of natural numbers, or you call them natural integers, which is the same thing. Great. And then later on, after some time, then people started discovering more and more. After discovering the opposite of of those natural numbers, then they started to think of in terms of fractions. And in terms of a fraction, they discovered that after some time, that there are some numbers that they don't fit into this one. So basically, say if I have a sheep and I want to distribute it to a number, I slaughter it, then everyone get a small portion. Then they discovered that, okay, if I have 5 persons here, then I'm taking one sheep and I'm distributing it into all of those. So basically what I can do is either slaughter it or sell it and then take the amount that then distribute it to this. So then the notion has become of numbers has getting to change slightly. So they realize that there are some specific type of numbers that they don't fit into this natural one. So mathematician has to come with a special notion to write this, and those are the numbers. Let's say you can see that if you have 1, you divide it by 2, you have 1 divided by 3, you have 1 divided by 4, and so on and so forth. You can have 2 divided by 3, you can have 5 divided by 4, and so on and so forth. So these kind of fractions, they are very close to nothing, but they are not nothing in reality. So, and they are close to some specific numbers, and they are not close in a specific way that they could literally. So the mathematician come up with a notion to represent them, saying that, okay, including they say that we can write them as an integer on top and an integer in the denominator, and then because of that the one on top can be anything. It can be an integer in Z, it can be a natural number. The same way for the one at the bottom. However, they realize that you cannot do something like this, because they realize that you can't have 3 cows and then you divide them with nothing. You can't have 3 sheep divide them with nothing. You can't have 2 goats and then divide them with nothing. They said that, okay, this option here, the mathematician picked up that this option here is not viable. So because this option is not an easy viable one, so then they said that, okay, we can characterize those numbers that are not small, not big, and somehow they can be anywhere. Even if you take a normal number, it will still be among them. Now the question is that if we try to fill in this notion that they're trying to get away with, they say that the one in the denominator should not be 0, it should not be nothing. So with that idea in hand, then they say, okay, then in that case we have a different set as well. And then they come up with this notion and say we have A divided by B. Please, you don't worry if you see sometimes people use P divided by Q. It's the same thing. It's just that I prefer to start with A and B. With B different from 0. And then both A and B, you can take them actually. In fact, if someone from a French country, they usually take A is in N and B is in Z, but it doesn't matter wherever you take them, as long as B is not 0. So you see that A is in Z, which means A can literally be 0. So it means that 0 on its own, you can write it as 0 divided by 1. You can write it as 0 divided by 2. You can write it as 0 divided by 3, and so on and so on and so forth. So it's not going to stop. You can even take 0 divided by 1,000,000. It wouldn't make a difference. So it will just be a 0. So you have nothing. You are dividing it to some numbers, so it doesn't affect. And then this set here, it's called the set of rational numbers. So then it's given this name, Q. And this is how it's been characterized. So it's kind of, you have some divisions with the denominator not being 0, but the numerator can be any number. It can be an integer, it can be a natural integer, which means those are positive one. It can be, in fact, even a negative number. So which means that even if I take 3, 3 is the number that I can divide it by 1. So it means that here, in that characterization, A is equal to 3 and B is equal to 1. Of course, 1 is different from 0, so it satisfies that definition. So any number. And then later on, because of the pyramid, so if you all heard of the pyramid in Egypt, built by the Pharaoh and all the other communities, people have started to discover, thanks to Euler's technique, they have started to discover that, okay, let me first go and characterize this one here in terms of this way is it going to be. Because I said that any of the number inside, it can be here. So then this one, I'm going to call it our Q. So, and that is called the set of rational numbers. So which means that this complements Z. So Z is N and inside and everything outside N. Q is N and Z and everything outside the Z. So it means it's complementing Z. So it means it's complementing Z. So it means it's complementing Z. Who's the person? Can you please unmute? Alondiwe? Thank you. Because that's disturbing the flow. Okay. Now because thanks to them that people started measuring the size of and the length of the doors of those pyramids, and then they started discovering that it's giving them some very funny numbers that they cannot actually in reality be able to characterize them, and those numbers. I think now the mathematics has to take a different turn by discovering that once you have a circle, you can say that you have a diameter, you can say you have a radius, and then the circumferences, which I think most of you know that is 2 pi r. And then the notion of pi came in thanks to those houses were built by Pharaoh because of those calculations. And then that has given an idea to Euclid to use the notion of a circle, and then after that he comes up with the number of pi, and then he realized that there are some numbers like 22 divided by 7, which they fit into that definitions of A divided by B, with A equal to 22 and B equal to 7, and so on and so on and so forth. And those numbers, they are approximately close to pi, but they are not exactly. So then later on, I think thanks to Euclid and Euler, they gave it the name of pi after certain approximation and after working through some circles. Now with that in hand, they come up to discover that there are some numbers that they look very funny. Those kind of numbers who looked very funny, like let's say 1 divided by 3 or 10 divided by 3, there are some specific numbers that they fit close to the description of this A divided by B, but they don't belong there. So they are trying to now characterize those numbers. And among them, E also, thanks to Euler, also has been approximated using similar technique that was used for the pi, and so on and so forth. Then they come up with a different set. And that set is called the set of irrational numbers. So the set of irrational numbers, it doesn't have an exact characterization, but it has some numbers that they don't end after the division. And some numbers like pi, like square root, and so on and so on and so forth. If you take square root of 2, it doesn't satisfy that definition of A over B, with A different from 0. You see, A is the square root of 2, which is not an integer. So despite the B is 1 and it's different from 0, still the definition is not satisfied. So in that case, they try to characterize this kind of of numbers that include e, include pi, include so many other divisions that they never end, or those that they're going to repeat forever after certain things, right? So depending on how you write them, you can write them like this. Some other people write the other ones in this form to say that yes, this kind of repetition and so on.